At the end of every learning sequence in this course, we will have some exercises. And these practical exercises we will actually do in R. Those of you who take this course officially from my classes, you already know how to set up our environment and how to actually, you got a link to our basic course, which is required in order to do all these exercises. If you just watch these videos on YouTube, you can also find the link to this our basic course below this video. And then I highly recommend you to take this course, which tells you, first of all, how to set up our environment and also how to actually some basic things about our programming that is needed. Okay, so here I assume that you have already taken this course. And there will be two exercises, so two videos. First of all, I will repeat all the examples from this learning sequence with apple, sample with 10 apples, and then I'll also show you another example, a little bit more practical example. So let's start with apples. So I create a new script. I will call this, I'll save this script. So first of all, I need to make it a working directory here. And then I'll save this script. I'll call it lecture like block 11a. So that's the first exercise for this learning sequence. First of all, let's load the data. In this case, of course, you can load the data from Excel file or from any other files, but let's, because it's only 10 values, let me just enter them explicitly. So I create a variable x, which I then assign the following sequence of values. 9.4, it's exactly the values that I use in my presentation slides. 8.9, so this is the amount of sugar in 10 apples in grams per 100 gram of apple. 10.3, 10.7, and 10.4, right? So if I run this line, Control Enter or Command Enter, if you use Mac, you can see that I got a x as a numeric vector with 10 values, and these are the values. I can also write x and Control Enter or Command Enter, and then you can see all the values here. You can also use run if you want. So now let's simply do what we have done in the lecture. I will compute ranks, I will compute quantiles, percentiles, I'll make plots, everything that I showed you before, but now let's do it together. First of all, let's start with ranks. So it's easy, you simply say r equal to rank x, and then it will compute every value rank x. Rank for every value, so again, I show r, you can see that, for example, 8.9 has a rank of 1, you can see it here, because it's the smallest value, right? And then the largest value should have rank 10, and it's 10.7 indeed, right? So these are the ranks. So every value has its rank now. You can also sort the values. For example, sorting. So for example, I can say x sorted 1 equal to sort x, right? And then if I show you x as 1, you can see now the values are sorted. This is the smallest value. This is the largest value here, right? So it's as non-decreasing sequence. I can also sort it the other way around. So I can say x as 2 equal to sort x. And then I say decreasing, it's additional argument in my function sort, true. So it means that now sort in decreasing order, not increasing, right? And then if I show you the values, you can see that now it's just, this is the largest value and this is the smallest value. So now it's sorted in decreasing order. Okay. What else? The simplest plots, the strip chart. I'll just skip the comments. So strip chart x, strip chart x. Then you can see this is the strip chart. So you can see the values as points, and this is the x-axis. You can, of course, change the color of the values like you do in R. And then you can also add label, for example, like sugar, like, I don't know, gram, like this. And then you can see this is the blue, and this is the sugar in grams. Now let's recall that first two statistics that we learned were median and range. And this is how to compute it. So median x computes median. In this case, I don't save it. You can see I just compute it. And it's 9.85, exactly what we had also in our learning sequence. And if you want, you can save it, of course, into a variable. Then you can see it produces a variable md with this median value. Similarly, you can compute mean and max. Mean x mx is max x, and then you can see they also, because I saved them into variable mn and mx, you can see they appear here, 8.9 and 9.7. You can compute range just by subtracting minus mn. So this is the range, you can see 1.8. You can also call function range, but in this case it does not compute the difference, it computes both min and max as one vector. Okay. You can also, of course, add. You remember that I added these variables to this plot. Because I already have the plot, I can simply add these variables as line. I can say AB line, for example, AB line, C, MN, MD, MX. You can see first it will be minimum, median, and maximum. The order doesn't matter, but why I pointed on the order, because I also want to have line type. For example, for mean it will be dashed line, for median it will be dotted line, and for max it will be dashed line. So that's why I do it like this. And then you can see, let me see, I should say vertical lines. So this argument, it should be named argument V, means vertical lines. Now it should work. You can see indeed that this is mean, this is max, and this is the median. So now we kind of made the same plot as I showed you in the videos. Okay. You can also compute a lot of statistics by running summary. Summary. X, you can see that it computes the smallest value, the first quartile, the median, the average value, which we will discuss in the next learning sequence, and then the third quartile and the max, this the largest value. Okay. You can also compute quantiles. For example, if you want to compute quartiles, you can write like function quantile, then x, and then you need to specify, for example, 0.25 will compute the first quartile. You can see it corresponds to this one. And then if you write, for example, 0.5, it will compute the median, and so on and so forth. So you can also specify all this together like this, 0.5 and 0.75. So these are quartiles, you can see. And if you run it, you get 3 values together. However, if you compare these values with the ones that we calculated in the learning sequence, you will find out that it's not the same values. Because if you look at the help for quantile, you will find out, let me quantile, you will find out that actually there is a special argument, it's called type. You can see by default type equal to 7. If you scroll down and look at the type, you can see it's an integer between 1 and 9, selecting one of the 9 quantiles algorithms detailed below to be used. So I told you 7, but in fact in R it's 9 different algorithms to compute quantiles. And if you scroll down a little bit, you will find out all of them. So type 1, type 2, type 3, type 4, type 5, and so on and so forth. And then you can see type 7. This is how it's computed. It's rank minus 1 divided to number of samples minus 1, right? So this is the way it computes. The way we compute it, you remember the balanced quantiles. It looks like this. The rank minus 0.5 divided to n, and its type equal to 5. You can force, I simply copy and paste this, and then I can say use type equal to 5. And in this case, you will get the values, the same values as we got also in the learning sequence, in the videos. Okay. The next, let's make a percentile plot. In order to make a percentile plot, first of all, we need to sort the values, right? So we sort the values, sort x. So let's just check that they are sorted. Now we need to compute the percentage, right? So we can do it different ways, but I think the easiest way will be just to do it manually. You remember that like how we compute this, right? So we need n, it's a sample size. Let's length of x. I can just define it as n as well. And then look, this is what you need to do. You see, if you write 1 colon n, you will get a sequence 1, 2, 3. This is the rank, because now the values are sorted. We have the ranks also like just a sequence from 1 to 10. And then if I make a parenthesis around and subtract 0.5, you will get exactly this rank minus 0.5, right? And now what you need to do, you just need to divide every value to n, to the sample size, which I can do it by adding additional parentheses and divide it to n. And now we get the percentage, the percentiles, right? So we can save it to a variable p, like this. And now we can simply make a plot where I say x and X sorted X and P, right? So this is the percentile plot. Now, if you want to connect this, you can write it like this. The type of the plot is either B, it means both lines and points, or you can also write it like this. That will just cross the points. It's up to you which one you prefer. I will use B. I can also make it a blue. And then I can also add labels like sugar in grams, and then YLAB is percentage P. This is it, right? So it's exactly the plot that I showed you in the videos. So this is the percentage plot. And then, for example, if you want to show where the median is, you can just write like AB line, horizontal line at 0.5, color equal to red, and then line type, for example, dash it. So this is where the median is. And then you can see, for example, if I add vertical line, you remember I computed median before, it's located here, vertical line for MD, and then you can see it crosses exactly in this point. It crosses this line exactly in this point. So this is the median value. You can also show where for example, the quartiles here as well. Okay. The next is to compute these 5 main statistics. You already know that you can compute it using summary, but you can also compute it using a function that's called 5num x, and then it gives you this 5 main statistics: the smallest value, then the first quartile, the second quartile, the third quartile, and the largest value. Okay. Now the box plot. So if you write the box plot x, so this gives you the box plot, and you can see by default it's vertically oriented. You can make it horizontally oriented if you add additional argument, horizontal equal to true. So you can see now it's horizontally oriented. And of course, you can change color. For example, color equal to blue. That makes color inside. So maybe we can make it like light blue inside, and then maybe the border equal to blue. Then you can see this is how it looks like. You can play with the colors you want. So this is actually it. This is a very simple rank-based analysis. So you can compute different statistics. You can visualize these statistics using different plots and so on. Just one more thing. Let me introduce an outlier. You remember this is our x, and then this value 10.7. Let me change it to 15.7. So I just want to repeat the situation with outlier that I showed you before. In this case, I simply say xo equal to x. I make a copy. So xo will be the same as x. It's a copy. But then I say xo 9, it's exactly the value number 9, it's this one, is equal to 15.7. So I introduce outlier here, right? Now, if I make a strip chart, you can clearly see that xo strip chart. So you can clearly see that indeed we have an outlier here. And let's make a box plot for this in order to see if indeed box plot will be able to detect this as an outlier. You can see indeed, so this is clearly an outlier. This is the next smallest value, the next largest value. I can also make it horizontal equal to true, and then you can see this is the outlier. This is the next largest value here, right? You can actually save the calculations. So box plot is not only plot, it's also does a lot of calculations. You can save it to a variable. Let me use another like PL, for example, right? And then you can see that PL, it's a list. So it means it's a container with a lot of different outcomes. If you open this list, you will see this is statistics. Then N, it's a sample size. This is confidence interval. This is what we are going to learn later. This is an outlier. You can see detected an outlier and some other parameters. You can also write PL here and see all these things. So you have the statistics, mean, first quartile, second quartile. This is the third quartile, and max. And now it's not the max, it's a max without outlier. You remember that we had max as 15.7, but it's an outlier. So therefore we got the next largest value as a max, sample size, and this is the outlier, detected outlier. So that can be also useful. Okay. So that's what we have for the first exercise, and in the next video I'll show you one more.